Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson what I'm going to do is just expand upon the previous video lesson that I did on the Christmas lights. I'm going to just show you a slightly different way of doing the Chase 2 and the Chase 3 sequence, and show you one or two of the issues that will be caused by doing that. So previously, this is what I had done in order to put out the sequence. I used a static variable so that I could remember what the value of store was the last time this function run. This was important because I only do one movement of the sequence in each run of the function. That allows me then to go back to the while loop and check the value of port A before I do the next sequence, which means that I can break mid-sequence to one of the other sequences if the input has changed. Now I'm going to show you a method where that can't happen. In other words, where the sequence has to finish first, which it's not necessarily that this is incorrect. It's simply something you have to be aware of if you're designing it, so that if the design is such that you want it to break in the middle of the sequence, then obviously you can't do this, or you must find a way around it. And if you wanted to finish the sequence before you make a change in any given situation, then this is perfectly fine. So for the Chase 2 sequence, if you recall, this is where the sequence of the 1 goes from the least significant bit to the most significant bit, and then back to the least significant bit. So it goes up one bit at a time up to the most significant bit, but then makes a jump straight back to the least significant bit and goes back up again. So to do this, what we can do is we can do a for loop or a while loop. I'll do a for loop here. I'll say I is assigned 0, I smaller than 7, smaller than 7 or 8, smaller than 8, I plus plus. And we'll make that. Now obviously in order to do that I must create the variable I, so that's an integer. In fact, what I'm going to do is I'm going to set, to save space, integers are bigger than characters, and because my I value is only going from 0 up to 7, I don't really need it to be a full-size integer, which would probably be 2 bytes. So I'm going to set it as a character, even though it's not a letter. That's not important. So, and it also doesn't need to be a minus number. I'll call it I. Okay. I don't need this to be static because I don't need it to be remembered each time. It can be just reset and remade each time. So what I want to do then is I want to put a value out to port B, which is going to be the value of store, which of course we haven't set up. So and again, because store is only going to be is never going to be bigger than 1 byte, we can set that up as a character, non-signed character. So store, we'll do a delay. And then we'll shift by, so we'll shift store. So store shifted by 1 place. And this should happen 7 times. And then what will happen is it will go back. So the entire function, the function is called, we set up the character I and store as 0, 1. We put 0, 1 out to port B, we delay, we then shift it up by 1 position and go round again, and we do that 8 times effectively until it goes to the end, and then we're done at that stage. Okay. Now I'm just wondering, I may have gone 1 too far here if I actually do 8 shifts. We'll check it and just be absolutely certain. So. And then we'll go back and we'll change the other function. Okay, so the one that I'm checking is this one. So I want to see that it goes fully through the sequence. No, and it pops straight back to there, so that's working perfectly fine. Okay. Now, the issue that occurs here is that if I'm in the middle of the sequence and I change back to 0, so we're just going to check this. If I change back to 0 here, you can see that we're still going through that chase 2 sequence until we get around, and then it changes back. So that's the slight disadvantage in this particular case, if you consider it a disadvantage at all, is that when we make a change, it takes some time before that change takes effect, and that's because that function must fully finish before it goes round. Generally speaking, this would actually be considered a disadvantage, because if you consider that a user, in other words a human being, has actually pressed this input, they obviously clearly want the other chase sequence to run. They may not like to have that delay there. Okay, so that can be in the previous way that I showed you how to do it, that can solve that particular problem. But we'll also be looking at other situations in which in the next week or so, where we have to respond very, very quickly, and different methods for doing that. You haven't learned them all yet. So just to finish this off quickly, what we can do is we can change our chase 3 sequence to a similar style thing. So we'll take all of that. Once that for loop is finished, we'll make another for loop. I'm actually going to change the way I've written this, because it's better to kind of keep these tight together so that we can see them quite clearly. So again, this is going to run exactly 8 times, and in this case, we're going to run in the opposite direction. Okay. Now, the previous value of store will be that the 1 is in the most significant bit, so it'll start being brought down the other way. Okay. So again, we're going to test sequence 1, 1. Now, unfortunately, now it's still on sequence, because the way I set it up, it's still on sequence 2 until I get to there. And that seems to have broken, so there's a mistake there. Okay, so the issue there was, and it was what I was concerned about earlier, that I was just going one too far with my 8. The problem with this one, with going all the way to 7 jumps, is that it will actually jump it off the end. Not a particular issue in the first case here, but it is an issue here, where if it's moved off the end, it means that the store value will no longer have any 1s in it, and that causes it to fail. So we'll just take a quick look at this one running. Sorry, I've changed it to 8, and I shouldn't. I changed it back to 8, which I shouldn't have done. So I'll reset that running, and we'll take a look at our I/O pins. Okay. Now, so what I'm going to do is I'm going to set both of these to 1 to check our sequence, and we'll just watch it go up here, and back down it goes. And it goes back the way. Now, of course, if we change both of these to 0, what we find is that it has to go its full way through the sequence before it gets back again. So again, the same issue as previously. Okay, but that's another way of looking at doing the sequence. Again, it may not be optimal for our current situation, but it's perfectly fine as one example of how to solve the particular problem. If it must be that you can that when the user puts in an input that you must change immediately, then you would have to add extra code in order to make sure that you jump out at that point. Okay, so we'll leave it there for the moment.